Good morning, everyone. Welcome. Thanks for joining. I'm excited to be presenting for UTSA and the Open Cloud Institute. We're going to be going through today a fairly quick introduction to Elastic Security. We do have another presentation scheduled, I believe, in April, where one of my coworkers, James Spiteri, will be going into some more details about some of the capabilities. But today, I'm really focused on just getting a general feel for Elastic Security for anyone who may not have seen it before, or maybe hasn't seen some of the new features that we've come out with in the recent past. By way of introduction, my name is Dain Perkins. I am the security product marketing engineer at Elastic. I've been in information technology and information security for just about 30 years. I'm kind of sad to say. I was counting it up earlier to think when did I start, and it was 1993. Today I work with product management and product marketing and sort of an engineering and marketing role to develop, test, and really bring to life the Elastic Security story. In terms of background, where to start. I like the big picture. So when I look at information security holistically, whether it's been from a standpoint of buying, selling, designing, implementing, or managing information security technologies, I look at it from the lens of reducing risk and or optimizing costs. And I used to say reducing costs, but once you give up the budget, you never get it back. So we try to shoot for doing the most with what you have, as opposed to potentially reducing costs and maybe giving up that budget. So how do we go about doing that? What are we looking at? What are we trying to deal with? As I've worked with pretty much every SIM on the market in the past, the biggest challenges have always come down to data. There's too much of it. We're creating more and more every day between container environments, cloud environments, malware analysis, observability solutions. There's a huge amount of data being created, and dealing with that is at the core of most of the problems that I've seen in the different security technologies that I've used in the past. When we talk about these challenges, these security data challenges, what are they? And I think pretty much across the board, these are pretty general, pretty ubiquitous. Limited visibility. It's always hard to get all of the data into your SIM, into your security environment, to be able to analyze it. Oftentimes that amount of data, whether it's everything that you want to see or just a subset, is going to lead to too many alerts, too much noise, which is going to obfuscate and hide potentially suspicious and truly malicious behavior. That, combined with limited context of the information that you are seeing, means every alert you've got to triage, you've got to investigate, you've got to dig in to find out, is this real, or is this something that is a false positive? Is it something that I can pass on now to deal with another important event today? I spent a couple of years at two different AI threat detection companies in the past, and that was the big push. How do we determine what's real and what is something that I can save for later? And most importantly, in terms of the context of the users or the entities or the network ranges involved. Certain things, if it's PCI compliance, or it's the HR system, or it's the CEO's user account, these things are typically going to be more important than the kiosk at the front desk that has extremely limited access. So being able to contextualize that information has been a challenge. Um, Personally, I think flexibility has been the one thing that I can say without question has always been a problem for me. There inevitably is something that I want to do, some pivot on data or some complex, really obnoxious query that I want to run that I can't in many of the systems that I've used in the past. Sometimes that comes down to a question of scaling, which again comes down to cost. And then as I said, I started 30 years ago. My first foray into a SIM environment was the predecessor to NetWitness, and we were looking at a couple terabytes of storage, if that, for a large implementation. Now that's child's play. Adding cloud, the complexities involved with multi-cloud, if you're using Azure and AWS, GCP, egress costs for pulling data from these different environments, not to mention the data governance and sovereignty issues. There's a lot to consider. The common denominator across all of these is almost always cost. We have limited budgets, we have limited staff, and we have to do the best with what we have. And that's where we're really looking at Elastic at how can we modernize security operations? How can we build something that will help our customers slow down the attackers, speed up the defenders and the analysts, and optimize operations and budgets, making it flexible, efficient, and effective at scale. That's the target. At first glance, it seems really straightforward. It seems like, hey, that's a clear set of goals. How we go about doing these things and how we actually do these things in a real world environment is not quite as straightforward. So that's the quick background. Now we're just going to go through some demo environments so that you can see what it is we do, how we deal with some different environments. I've got a demo architecture diagram. This is actually built in Elastic. We have a portion of the platform called Canvas, where you can build presentations if you wanted to roll up statistics to the CISO or provide the SOC manager with operational statistics. You can effectively build a live PowerPoint. In this case, I've just pulled some stuff from Google Slides so that we can go over the architecture. I've got a microservices environment built on Kubernetes. It's the Google Hipster Shop e-commerce environment. It's running in GCP on a GKE cluster. I've got an EKS Kubernetes cluster running in Amazon to get some additional information out of there. We've got a handful of endpoints, Linux boxes, Windows boxes, and a sandboxed environment. I've got a development system here that's a part of our e-commerce environment. We're offering ads, and we had some problems, so we're checking those ads periodically to make sure that our clients are getting what they're paying for. We've got one host that has our Elastic Agent that's got our security integrations for things like Tenable, vulnerability scanning, OTX anomaly and abuse threat intel. We've got a connection out to both Tines SOAR platform and ServiceNow. And from that cross-cluster perspective, we are pulling data from our GCP, AWS, and Azure environments. But instead of actually going through the process of grabbing all that data and backhauling it to one central cluster, we've actually got smaller clusters in each environment doing our monitoring with a full Elastic Security implementation available there. But we're using distributed search so that you can pull just the data that you need from those clusters. So all the operations that we'll see in our main security cluster, that's pulling from all those other environments as well if we need them to. So here's our hipster shop, standard e-commerce application. I've got some products in here. I've got some Elasticsearch search capabilities going on where we're pulling up products you might like based on the bike, and I can add that to my cart and I can place my order, and that's great. So that's what we have there. Now I'm going to back up a little bit, and this is our development system. It is our victim in this demo, and we've got file integrity monitoring. I'm pulling Linux metrics, CPU, processor, memory, that sort of thing. I've got a packet capture running so that we're getting network flow, we're getting protocol information. I have OS Query Manager deployed, and I can deploy this with my Elastic Agent environment. So all of our agents have OS Query Manager available, so we can use that to respond to threats. We can pull information. We've got our standard system, and we have our what we now call Elastic Defend. So this is actually our endpoint XDR. I tend to just call it endpoint security, but it is an advanced endpoint security tool, XDR capable, where we're hauling back all that data to Elastic SIEM and keeping it for as long as you want to keep it. Generally, I like to keep things as long as I can, but we all know that the cost is always a concern. So we have a capability to use snapshots where you can live search objects, store backups. So you can take your data, have it in the hot tier, and then move it along our data tiers into what we call our frozen tier. And instead of paying for SSD storage or EBS storage, save it off to an AWS bucket, S3 bucket, a GCP bucket, and save it at the lowest possible cost while still having it searchable live. So our endpoint security, now called Elastic Defend. Here's our actual integration, and we can see all the data that we're capable of bringing in, the different integration policies that we have deployed, the assets that are involved. In this case, we've got a host view, the different settings, and we can update this and manage it right from this central environment. If we go back to the actual, come on, one more. If we go back to our actual policy, we can see the different capabilities. So we have trusted applications, so you can create different lists of applications that you want to whitelist in your environment. We can filter events, another good way to cut down on data usage when cost is an issue. Host isolation exceptions, so we can isolate hosts with Elastic Defend. And in this way, typically you're going to want to still have the ability to reach a system provisioning server or still send data to your SIEM, so you can isolate your host without cutting off that connectivity. A full block list, and then from a policy standpoint, we've got malware protections for Windows, Mac, and Linux. We've got ransomware protection for Windows, memory threat protection available across Windows, Mac, and Linux, malicious behavior protections, excuse me, credential hardening for Windows, and specifics on all the different types of events you might want to collect. In Linux, we've recently released an eBPF terminal output capture, where you can actually see literally everything that's going on in a live interactive session. And all of these are available. No agent costs or anything like that. It's a part of the Elastic security product. So where does that leave us? Well, here's our alert screen, and this is Elastic SIEM. I've got it keyed to earlier this morning, where I created an attack on that dev system. And you can see we've got a bunch of different alerts. It's a demo system, so it's not tuned for anything. We're getting a lot of threat intel matches My thoughts on these, whether or not they're really useful, I find it depends heavily on what feeds you're using and how you're managing them. But we've got a bunch of different ways that we can look at all of these different alerts. The first one down at the bottom here is a malware prevention alert. So I can open up my details on that alert. This is coming from Elastic Defend. So this is our endpoint XDR agent. In this case, we see a file was attempted to compile, and we've got a whole bunch of information. It's this Linux exploit. I wrote it, so I happen to know that it's trying to compile dirty pipe to try and get to root access. We've got some insights, related cases, related alerts by session. So based on the actual session on the host system that was showing this alert, related alerts by process ancestry, and we've got some host risk and user risk details that are an aggregate of all the things that we've seen from the hosts and users involved. Now, right away, I know that this is bad. I know that something is going on, so I can choose to take action. I can add it to a case. I can mark it as acknowledged if I know it's a false positive. I can add an exception. I can also isolate that host or get into a little more creative response actions. So I've got the help open here, and we can isolate the host, release the host. This was all done earlier today, but I can pull the host for a status. I can get the process information, and instead of isolating the full host, if I felt it was appropriate, I could simply isolate this Java process, or excuse me, kill this or suspend this Java process so that I have time to investigate and find out what's going on. Now, if we start digging through some of these other alerts, I'm actually going to jump to this log4shell activity dynamic. So this is a new feature that we released in version 8.6.1. This is actually across, anything that has rules populated with MITRE ATT&CK tactics and techniques, and you can customize these for your own environments. This is our correlation rule engine EQL. And what I'm doing is looking for effectively some malicious endpoint activity followed by the types of things that are indicative of log4shell. So I could be looking for connections to DNS, HTTP, LDAP servers, whatever's appropriate for my environment. Now, if I scroll down, I've got my same insights, but I've also got this investigation guide. So I've been able to customize how I want my analysts to respond to these alerts. And I've got some, it's a demo rule utilizing EQL. And then I've got an OS query populated right down at the bottom. So when I see this alert, I can click that link. It's going to bring up an OS query integration, and I can now run that query against the host that is involved in this particular alert. In this case, I am going to be looking for specifically things that are potentially open to the log4shell attack. Nothing exciting about the log4shell attack, nothing crazy. It's fairly straightforward, but I can quickly and easily investigate, is this real? Is this something that I have vulnerable assets involved? And then decide what I need to do about it from there. I can view the raw data right from here. I can build a visualization. I can add it to an investigation, or I can add it to a case for all these events so that I know what's going on and can take that information and provide it to, say, the next level analyst or whoever else needs to be investigating these alerts. In addition, we've got the capability to add custom analysis, custom insights. In this case, process prevalence. So I'm actually looking at how often have I seen records about this particular process. This particular process is Java. So I'm going to see a huge number of these in this case, I'm looking back almost a year. If I wanted to break that down a little bit more, I could choose to only look at certain types of events. So in this case, I'm going to look at just signal, which is our internal Elastic name for alerts that we've built out, and I don't have any more. So that's a good sign. I don't have anything for this particular Java process. I can also check alerts, which might also include external alerts, and I can investigate however I want from this live timeline to get down to exactly what's going on. Additionally, if we look at, we'll take a look at the suspicious Java child process. I've got, again, the investigate and timeline, which we just saw. We can also add to a case. I can add, we're going to end in 10 minutes, so I'm going to make this extremely quick so we can get to any questions if necessary. If we check our analyzer view, for things that are including process information, whether that's coming from Elastic Endpoint or any other integration, we can actually get a visual guide to exactly what's going on. So if I'm going to zoom out just a little bit in here. So my Java process is what started this. And it opened up a shell, downloaded some file from GitHub. It downloaded effectively a dirty pipe exploit. Attempted to compile it, attempted to change the permissions on that file to make it executable, and then tried to, in this case, we're doing this is the full command. So after we've compiled it and changed the permissions, now I'm going to try and run it. And that shows me the entire process tree of what's going on. So if it's something new, and this is fairly straightforward, it's log4shell, we know what it is. Dirty pipe, we know what it is. If it were something that we hadn't seen before, it gives us a really, especially for those of us who are maybe not as comfortable digging into Linux terminal commands, shell scripts, that sort of thing, gives us a great overview and a great detail as well on everything that went into this particular attack. On top of that, we have session view, which gives us that low-level analysis of everything that was actually going on in the system from a system standpoint. And that's going to come up. You can see we've got our, I can expand and contract all the different child processes. I've got all of my alerts tied in here. So here's our malicious prevention alert from Elastic Defend. Keep opening up through. There's another malicious prevention alert. So anything file or alert session related will show up, so we can see it from whatever standpoint is most effective for our team, and it's gonna differ depending upon the people involved. So that's a quick overview of our alert core SIM functionality. One of the things that I like about our offering, and truly one of the things that brought me to Elastic 4 years ago when I hunted down my old boss, was the possibility of collapsing a number of tools into a single environment. Savings on licensing, savings on management, savings on operational expense, easier to deal with. If I don't have to bounce back and forth between 4, 5, 10 different applications, that means I'm going to be able to get to what I need faster. Are we going to cover everything for everyone? No, we're not. And we integrate with hundreds of external tools, and I see that number growing every time there's a new release. So if there's something that you need to keep, you can keep it and you can integrate it. Here we've got our cloud posture assessment. So we've started with CIS for vanilla Kubernetes and EKS. There are plans for expanding this into other cloud and container environments, but you can see we We've got quite a few Kubernetes benchmarks that we are failing. We can easily check these and start going through to decide what do we need to do about this? How do we need to remediate these issues? And right here, excuse me, in each of these is a general remediation overview, details about the rule and the resource, as well as the raw data. Pretty much anytime you see anything, you can always get to the raw data. We've also got the Kubernetes environment. Now this is actually leveraging, again, Elastic Defend and Elastic Agent deployed as a daemon set on Kubernetes. And in this case, I've got my main ecom GKE cluster, and then I've got my my staging ecom cluster. That one happens to be an EKS. Now, a lot of the things that we see here are non-interactive. So it's the Kubernetes system doing what Kubernetes does. I might not be interested in that. However, if I look at interactive sessions, I might be interested in that. Why are people logging into a shell interactively on a Kubernetes pod, and what are they doing? And with a quick click, I've brought this down to a couple of entries, and this was literally me executing a shell in a Kubernetes pod this morning. And I can dig in and find out exactly what's going on, what is somebody doing, again, either from the analyzer viewpoint, or I can do it from that session view that we saw previously. So as I expect, we've got a run C for the container. And then if we go all the way down to the end, you've got a bash shell and a who am I on this one, I believe. No, I ran an Elastic Agent version. The next one is actually the who am I. We integrate threat intelligence. So if you are using feeds today, I think we're up to 6 or 7 different threat provider, including OTX, abuse.ch, anomaly, and a number of others. This happens to be a pretty basic OTX feed, but I've got file names, I've got IPs, and I've got rules that we saw creating alerts earlier that are built off from this data dynamically. Finally, and this seems a little odd, but observability seems to me to be something that's important to security. Availability, excuse me, has always been a core tenet. And because I've got my observability solution built in, that log4shell attack is HTTPS. So if I'm using something on the wire, I might not see that. I might not ever see what's going on. But if I have observability deployed for the same environment, I can actually dig down into what's going on and potentially get down to an actual root cause of what started this problem. Now, again, it's log4shell. We know what it is. If we didn't, here it is. And all I have to do is dig into that observability screen, single application, and I can get right down to the root cause. Where did this come from? How did it start? What do I need to do about it? Where if I didn't have that all in the same place, it might be a whole lot harder to get there. Whoops. All right, so we have about 2 minutes. I will be happy to stay on for any questions, although this is probably going to close. Another important thing from our standpoint is our Elastic Security Labs. So we have a fantastic group of threat researchers and malware analysis folks that are constantly looking at the threats that are out there. They are working to update our detection rules, our malicious detection rules, out of the box, unsupervised and supervised machine learning models. And they're a great resource that brings a lot of great capabilities to our environment. Whatever time we have for questions, I'm 100% open to anything anyone has. Thank you so much for joining. If you want to play around, you can sign up for a free trial at cloud.elastic.co. No credit card needed. Just click the link and off you go.